And you do know the answer, correct?
What?
You do know the answer, right?
No,
okay, good. I haven't messed. We'll mess with it when class is over. All right, find your seats.
No, sir, but we're gonna be in Miss Kittle's room today, not yours.
I thought it was going to be a repeat of what yesterday was like.
No, we're leaving you.
Okay.
You know, 7B had math homework today.
7.
No.
That's just
No, they didn't. Because they took the semester. I didn't teach them class. Tomorrow they will. Why? Who's? You know.
Tutor David after.
Oh, David, right.
I've had many people tell me that. People had the argument
Hey, sir, do you have any notebook paper?
I don't.
You
Do you have any graph paper I could borrow?
I do, but don't grab more than one sheet.
Okay, do you have any tape I could borrow?
I have no tape. I have staples.
It's true.
Why?
Deny that.
What?
There's literally no way to deny that. It's just a fact.
I think Jack, you need to let it go.
Yeah.
I think they need to agree with me.
I think Jack
I've never
chill
this guy.
out.
Have you never met me before?
That's true. That is true.
No, I haven't.
Jack,
I will say that I speak from experience in the realm of interpersonal relationships, and you just usually get more friends by not being argumentative than you do by being argumentative. Yeah. Even though I as well have that.
Friends then argue.
I as well have that problem of wanting to always win the argument, and my wife lets me know that all the time. That's all I care about. I don't care about.
That's
the
why I was
relationship.
taking rhetoric and debate.
Agreed. It should be a pretty good class.
Jack is freaking arguments. Because I give my point of view. Oh my gosh, I need to explain something that happened in science. So me and Jack and I were having a conversation, and I'm like, and then he said science works because it's science. And he won't say anything else on that basis.
Well, you said that science is wrong.
No, I didn't. I said that science has facts and then it has things that aren't even proven yet. You said science works because it's science.
It's not that restate what you said. You said that science doesn't make sense, is what you said first.
Science doesn't make sense. There's many things we don't make sense of.
No, you said science doesn't make sense.
Okay, but that
As
could
in
be
the
his
whole
opinion.
science.
That science doesn't make sense to him.
It's not an opinion, it's just the wrong fact. You don't
That's
understand
he doesn't
opinion is.
understand facts and opinions.
Not an opinion.
I think where you're trying to reach for is that
You guys never even see it.
is science ever wrong? And I would argue that science is not wrong because the current process allows for a better refinement of what is the truth.
True, but the process can always be wrong. There's no way.
But
there is currently no way to have 100% accuracy
Agreed,
in
but-
any science.
But science
is not figuring out what something is. Science is the inner workings of the world. Science is always right.
Science is the process of finding that out. And
So-
through that process, we may very well stumble onto something that's right or wrong, but eventually, in the investigation of all things.
Okay, so you and I have very different definitions.
And that's what I was trying to explain.
So what do you think science is?
Science is the way the world works in a factual basis.
I don't think we're that far away from definitions.
Yeah, but you're thinking about the discoverment of my
So
definition of science.
are you saying, Jack, that every process, every equation, every formula in science isn't science?
No.
Because
that is
your
science.
definition says that none of that is science.
No, my definition says that all of it is science.
But you have, in your definition doesn't define
I
that.
don't think you understand
Definitions
what
have to define what they're talking about, otherwise.
Do we realize that McKinley hasn't said a single word since we've been in this room?
Oh yes, I know.
He's not
He's
feeling
sad boy. He has
You
got.
okay?
Look,
He
I'm
went to the
saying
nurse,
that
but his
science
parents didn't
is the way the
All right.
world works in a factual
McKinley, if you
basis.
gotta run out.
Right.
Run out.
So every equation that has come from the world is true.
All right.
So your definition.
Let's get some math done.
So your definition.
Here we
Jack,
go.
is
Here we
how
go.
the world works.
Dan,
with these
Jack.
formulas.
Let it go.
Right. John,
That's got to be part
I
of the
want
definition.
you both to be married at some point, so you gotta learn how to let it go.
hopefully.
All right. Questions on the homework?
Oh,
I think we did most.
18.
18. 18, show that the vector 4, -5, and 5, 12 are perpendicular. So the issue here is that, well, there's a couple different ways of thinking about it. There's 4, -5, and what?
15 and 12.
15 and 12. The way I taught in the class was I said compare the slopes.
12, not 2.
Compare the slopes of those vectors. In reality, what you're doing is you're the direction of the vector. Now, remember, this is written as not change in y over change in x, but it's a change in x over change in y. So if I wrote this as a slope, it would be -5 over 4. And this one would be what? 12 over 15. Now, those are literally the slopes of the drawn vector.
And they're opposite reciprocals.
And they're opposite. If you reduce this, they're opposite reciprocals. So that would reduce to 4 over 5. Okay. All right. Or you could multiply them together. We're supposed to get -1, right?
Yeah.
If we literally, if we multiply these together, cross reduce, 1, 3, 1, 3, we get -3 over 3, which is -1. It's so very infrequently that I multiply the two together to get -1, but you can do that. All right, anything else? All right, Ben, read off the answers. Go.
Oh,
just the evens.
They're lines. Oh yeah, the way those things. All right.
Except for the make a sketch.
Number 2. AB with the weird half an arrow on top. Vector AB equals 6, 8.
Keep going.
And then the
distance.
The distance.
The magnitude.
The magnitude is 10.
Very good. 4.
What did you have them do it? We're gonna be here all day.
Number 4. Well, you see, with this, okay, -3, -3. Magnitude is 3√2.
Number 6.
4, -2, square root 19.
No. 4 -4 2 is correct, but the magnitude's wrong. It should be 2√5. Yes?
Okay, I didn't simplify it, so what?
Yeah, but what did you say the answer was? You said 19.
You said square root of 18 is what you said.
What? I did not say 18.
Because that would not be 2√5.
And neither would 19.
Neither would 19.
It's 20.
It'd be 20.
You definitely did not say 20.
Well,
Yeah.
wait, but 4...
-4 2, so square both, so that'd be 16 plus 4, which is
it.
20. Okay.
Okay.
All right. Number 8.
-6, 5.
You got it backwards.
6, -5 is the same thing.
No, that
It's
would
not
be
the
a
same
vector
thing,
pointing in
but
a different direction.
It's the different direction, but it's still the same line. Still the same vector.
No.
If you're kicking a ball this way, is that the exact same as
It's the
kicking a ball
same
that way?
line, but it's not the same vector.
Well, what
What's the magnitude?
Square root of 61.
Yes. Number 10.
3, 6, 3√5.
Where are my answers?
Wait, that's number 9, my bad.
Yeah, you don't
That's number 9.
Oh, yeah. 10,
10,
12, and
12.
14 are draw, so go to 16.
16. I got.
Oh, actually, answers are going to vary because it could be anything that's a scalar.
That's true.
Right. So how about 18?
-1.
Yes.
20. I got 5, 7.
Yes.
22. -4, 8.
Yes.
24, 7, 5.
7, 6 is what the book says.
That's what I got. But let's let me mark that wrong. And then 26. The parallel.
Well, we talked about that one in class. Okay. Cool. Madison, if that audio didn't come through for the answers and you need the answers, send me a chat. All right. Somewhere here.
You want to pick up the homework?
I do.
Hey, you don't need this homework today.
Why? Well, not from you. You just call them all the answers.
Oh, so you don't want mine?
No, I want to.
Oh,
As soon as I start getting lazy, then you guys will start getting lazy. I don't need to do the homework because.
Yeah, but that had no bother with the rest of it.
I got
You have OCD?
In major, yes.
I have a little bit of it. There's people that have debilitating OCD. You can't even walk out of their house. Gotta wash your hands. To the door. Oh wait, my hands are dirty. Wash your hands. Go to the door. Oh wait, my hands are dirty. Wash your hands.
I'd leave the door open.
My clicker died. I don't have batteries, so I have to play lazy teacher here and click from my computer. All right. Look on the board. Calendar. Yes. We said yesterday I'll probably do dilation, so it probably won't be 14-1A. We will take quiz. The quiz will be on yesterday. I'm a little bit worried, especially with my 10th graders, that they didn't really do 13-1, 2, and 3 during quarantine. So I'm going to make the quiz on 13-4, 5, and 6A. So yesterday's class was on vectors, and you'll get today's class. That'll be what the quiz is on. What's up? Which one? Well, you're going to see when I get there.
Graphing, linear, and equation.
All right. Here is your homework.
Wow, that doesn't seem like a lot.
No, today's a very quick class.
Oh, why? Because we're doing this.
It's just midpoint. Literally, it's just midpoint. I can't. The book basically proves the midpoint, and that's it. That's the whole darn thing. It just find the midpoint of a segment. So, yeah. Sure.
I have a question. Can Jack and I sharpen this pencil?
Are you making an argument?
Yes.
Because everything's arguable?
Yes.
Then you're arguing his point.
Yes, I am.
Oh, I was arguing with him. I was arguing with him.
Wait, if everything
Hey, he's
is
stabbing with
arguable,
his
though,
pencil.
then everything being arguable
30
is
seconds ago,
arguable.
stabbing with his
Right.
pencil.
If it's arguable that
Yeah,
everything's
it's arguable. It doesn't mean you're right.
Right.
You guys realize
That's a good paradox.
No, it's not paradox because it's just arguable. It doesn't mean that it's wrong.
Yeah,
It means
that's-
that it's arguable.
I got you. I got you. That's why we would say paradox, not a, or would we call that
It's not
irony?
paradox.
We call that irony? Would that be ironical?
It'd be ironic, but not paradox.
Okay. Sometimes paradox and irony lead me to question whether or not I really understand the difference between the two. All right, midpoint formula. Pretty easy day. I mean, we've been using the fact that midpoints exist since pretty much chapter 1, but we never proved we actually didn't have the formula yet. All right, so think about this. I have a horizontal segment, and I'm claiming that D is the midpoint of segment CE. How do I know that's true? Given that information, how do I know that D, even though it claims that D is the midpoint of C, how do I know it's the midpoint? And it's a horizontal line. I left that part out. I mean, how would you prove that D is the midpoint?
How would I prove? Sorry, I was trying to figure out. Prove that D is the midpoint?
How do you prove that? I should have, instead of saying D is the midpoint, I should have been saying that CE is a horizontal segment. Prove that D is the midpoint.
You could say that there is between 2 and -1, there's 3 distance, and between 2 and.
So you're looking at what, the X values?
Yes.
Okay.
Because
All right, I'll buy that. That sounds like a pretty valid argument. Well, because by the definition of midpoint, a point that is midway of a given segment, he just showed that mathematically that it's 3 away from point C and 3 away from point E. Therefore, it's got to be the midpoint. So what's the formula for midpoint? Literally, what did you just do?
I just subtracted.
Did you subtract?
I counted.
Well, look at the X value of the midpoint. It's 2.
I subtracted, yeah.
Did you subtract?
I did.
What did you do?
2 minus -1.
Yeah, but that wouldn't give you the coordinates of the midpoint.
I mean, it didn't give me the coordinates. It gave me the proof.
How would
That's
we
what
get?
it did.
How did we get the 2 in the D coordinate?
You do 5 minus -1 divided by 2.
That would give you 3, not 2.
That would be the distance from D.
Yeah, but so how do we get to the 2 value of the point D?
Change in X minus D.
Well, you're making this way complicated.
That is the answer.
Ben, help us out.
All right.
How do we get, you see point D? Jack proved it is the midpoint.
Yeah.
Look at the X value. It's 2. Where did the 2 come from? Agreed. But why is it not a 5? Why is it a 2?
Well, you see, 5 is the E point, and 5 can't be the same thing because of the
Okay,
distance.
granted. I got you. But why is the X value of the midpoint D at 2?
You have to add them and divide it by 2.
You take you simply add them, and then you divide it by 2.
Genius, Ben. What are you doing?
All right. So why are you not clicking here?
Dead.
It's not clicking.
It died.
I don't know. Why is it not clicking?
You cancel out every. Oh. Whoa. Oh. Oh.
There it goes.
Oh.
All right. So yes, that's what you do. So in a more general sense, and we're talking about just the X value, not the Y value, but in a more general sense, then we take the 2 X values of the endpoints, add them together, divide by 2, right? All right, guess what I'm going to show you next?
Let me guess. Maybe how to prove it.
No.
Why?
I'm going to show you the y. So what picture am I going to show you now?
3 plus 3 divided by 2 is 3.
Yeah, but what picture am I going to show you?
Up vertical.
I'm going to show you a vertical line. So different one. I'm claiming that G is the midpoint. So where did this -1 come from?
You add them together and divide by 2.
We add the y values and divide by 2. All right. We put those together when we get the midpoint formula that you've already forgotten from pre-algebra and algebra 1.
X1 plus x2, x1 plus x2 over 2 plus, no, comma, y1 plus y2.
Okay. Now, by the way, this is not a proof what I just did because I just chose 2 points. You saw a pattern, and yes, it is the formula, by the way, but we got to prove it in a more general form. So once again, we have an impossible task of trying to prove it true for all segments. So we reach back to coordinate geometry. We throw a given segment on the coordinate plane, and just the mere fact that we've thrown it on the coordinate plane, we've got an x and a y axis, somehow allows me to prove it in the more general sense for all segments, that the formula for midpoint is exactly what you said. You take the 2 x values, add them together, divide by 2, comma, take the 2 y values. So, by the way, how did we prove this for parallel and perpendicular lines? What did we basically make? Remember the proof?
We made 2 angles.
Yeah, we had angles, but we also made triangles. So, well, we'll see. But in general sense, it's high school math, so there seems to be always a triangle involved. So it is a complicated proof, but we're basically going to do similar method. I'm going to start off by making two points. I want to make the point R, and the point R connects P and Q with a horizontal and a vertical line. Okay, it's a little bit hard to see, but the value of R now would be, let's see, it's a cross, so it's x2 across, and it's y1 going up and down. So the point of R is x2. Can you see that, or is that too small? Okay, it's also in your book, by the way. All right, so we got a triangle. In fact, we got a right triangle. We're not going to do Pythagorean theorem or anything like that. Here's a nifty point. Now, notice you're given that M is the midpoint, right? M is the midpoint. We're just trying to prove that its coordinates are that formula right there, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. We're going to reach way back to chapter 5 to help us out. Way back in chapter 5. I'm going to make a rectangle, right? I'm going to go from M, right? I'm going to construct point T. I'm going to go from M to T. Now, T is going to be on QR. That's the vertical part. And then from M, I'm going to drop down to that other dotted red line. I'm going to put an S. And MT is going to be parallel to PR, and MS is going to be parallel to QR. Parallel, not perpendicular, parallel. Now, it may or may not be perpendicular. We don't know yet. It turns out it is. Now I made that. That was my construction, right? So we got that M is the midpoint, and we got that MT is parallel to PR, and MS is parallel to QR. Now, why did I do that? It's because we had this theorem, something about parallel and midpoints. And this is one that you will forget. You will forget. I got to draw some tick marks. We found a long time ago that if you had a triangle, oops, it doesn't have to be a right triangle, by the way. If you have a triangle and you have a segment that cuts this into equal parts, what can you say about these? Yeah, and this was a long time ago, chapter 5. That if you have but this line right here has to be parallel to the bottom. I got 2 of those. By the way, M is the midpoint. So if these are congruent, then these have to be congruent. If these are congruent, then these have to be congruent. Just by that one construction right there.
So you can say that those triangles are...
This is 510, I believe. 510. So 510 basically says if that occurs, well, then S has to be the S. It doesn't say that S is the midpoint. That's not what 510 says. 510 just says it breaks the other side into congruent parts. Well, if it breaks into congruent parts, then S is the midpoint of PR, and T is the midpoint of QR. Now, why is that important? Well, if we broke those sides into congruent parts, well, check it out. We have what the previous slide showed us. The previous slide, I showed you what the midpoint was of a horizontal and a vertical line. So look at PR. What are the coordinates of S? What are the coordinates of S? I need a new pen. What are the coordinates of S? You can't see, this does say X2 though. I gotta prove that for next year. So S right here would be X1, this point and that point. That's X1 plus X2. And then we said, what do we do with that? Over 2. And what's point T?
Is Y1.
X2 plus X.
It's vertical.
Y1 plus Y2.
And you could write those in order, by the way. And why is that important? Because that's also the value of M. Right? Because M right here would be the same X value as S and the same Y value as T. And there you go. Done. That's a pretty nifty proof. So that's 13.5, which is basically something we've been using since pre-algebra. I gave you this in pre-algebra. 2 years ago. 3 years, 2.5 years ago. Yeah, 2.5 years ago. I had you for pre-algebra. Man, time flies. That was 2.5 years ago. Yep. You guys weren't even teenagers when I taught you in 7th grade. You were about to become teenagers.
That's not the end of it.
I said you were about to become teenagers. Anna's the oldest. Who's the youngest? I would not have guessed that.
My birthday is not till September.
Nice. So you literally could still be in 8th grade.
Yeah, but I was homeschooled till 7th.
Yeah. Well, you made the right choice. Because you're not an 8th grader. There's occasion, there's times when you can look at a kid and you say, wow, that kid is definitely not on the maturity or the physical maturity as everyone else in the class, but you blend in with everyone else. My oldest was a September kid too. My youngest is a July. My oldest is a September. We did the same thing. She was ready for kindergarten. She could already read and count and do adding, subtracting. All right, we good? I'm not gonna lie. This is not a challenging section. So they're gonna just basically ask you to calculate the midpoint. So this was more of an 8th grade question right here. Calculate the midpoint. Well, you take the X values, add them together, divide by 2. Take the Y values. Can you make a mistake? You sure can. And it's usually a labeling thing. But as long as you label correctly and you plug the numbers in correctly, it's pretty straightforward of getting the answer. Now, remember, it is an ordered pair is the answer. I mean, I would always leave your answer as a fraction. I would never change it to a decimal unless you're required to. All right, so let's do a challenging one because that one was too easy. All right, Ben, read.
Given points A to 1 and B, show that P is on the perpendicular bisector of the line AB segments.
Well, how in the world are we going to prove that?
Well, you see, it's fairly simple. Well, you see, we know first we got to figure out the midpoint of A and B. So, yeah, I know, it's amazing. So doing this math, we get the midpoint is of A and B.
We already know the midpoint, it tells us.
No, that's P. The midpoint of A and B is 5, 3.
Because we don't know.
That's a math mistake.
No, P could be the midpoint.
Well, it's not.
Well, how do we know?
Because the midpoint's 5, 3.
Okay. Yes. Keep going.
So now we know the midpoint's 5 and 3. The there's something else.
So what do you want me to draw?
I want you to draw a graph, a quadrant run from
Why quadrant 1?
because they're all positive.
Oh, very nice.
From quadrant run, not quadrant run, and I want you to make it where the x is the maximum of 10 and the y is the maximum of 10.
Okay, what else you want me to draw?
Then I want you to draw A, B, and P. All right, now we can see that we've already calculated the midpoint. Here's the best part.
Oh, I haven't. Let me hold on. Let me catch up because I didn't have that on my diagram. You told me the midpoint was
5, 3.
5, 3. And he got that by saying 2 plus 8 is 10 divided by 2. 5 plus 1, 6. So what was that? 5, 3. You said?
Yes.
Okay. There's point M. Keep going.
Now, well, there's an easier way. There's a much easier way. Actually, no, we need 5, 3. Now what we do,
You do need 5,
is
3.
we're going to take the slope of A and
Why are you calculating the slope?
because
I'm doing a teacher.
perpendicular lines
Or segments.
or segments, they all must have opposite slopes.
Not opposite slopes.
Equal.
Not equal.
Opposite.
Opposite reciprocals. Or you could say
-1.
when we multiply the two slopes together, we get -1.
So if
So we absolutely need 5, 3 because
so
now we got to calculate.
Let's name that M.
It is laying down.
It is? Okay, perfect. So you just got to figure out the slope of AM.
Okay.
And then multiply.
And by the way, we don't have to go AM. We could have done AB as well too.
True, but you need the.
But we
midpoint.
need M for the second
And
slope.
then we take the midpoint, and then we multiply the midpoint, the slope of AM times the slope of PM. AM and PM. What?
Oh, you know what? We made a mistake.
What's your mistake?
It says given points A and B show that P is on the perpendicular bisector.
Yeah.
We're never told that
No,
M is the midpoint.
We just made the midpoint.
We made the midpoint. Right.
Yeah.
Okay, keep going.
And then you just draw a line, and then you.
Yeah.
All right, so let's figure out the slope of AM.
Okay.
Fairly simple.
Rise over run.
2 over. Oh, I divided by 4 over 7.
No, 2.
2. You were right the first time.
That's right. My bad.
Just subtraction.
2 over 3.
2 over 3. So
let's try
before we do it, what must be the slope of the other one?
-3 over 2.
Okay, let's see if that happens.
All right. Well.
Opposite reciprocals.
All right.
Perpendicular,
6
so it's
we
perpendicular
got
bisector.
3 for the top one.
We better get -2.
You just proved it.
3 minus. Yep, -2.
Yeah.
Therefore, they are what
Okay.
you say they are.
Now, obviously I said that was a more challenging one. It wasn't that much more challenging, but that's the whole lesson. It's another one of those lessons that is what, a page and a half?
Yep. Actually, yeah.
It's a page and a third maybe. And they have a really large fonts too as well. Notice if you're looking at the book that they actually show that the distance is square root of 26. I'm going to say that's an extra step. It's not required because as you said, as you did, is we made point M where we wanted it to be. If they had told us that M was at what, 5, 3, if they had told us that M was at 5, 3, then we would have to prove that it was in fact the midpoint. But we just said, hey, there must be a midpoint. It exists. And if there is a midpoint, then we use the midpoint formula to find it was 5, 3. Okay. Yeah, I'm not sure why they could have thrown midpoint and the previous one all in one class, but they didn't. So maybe they're like, the kids are closing in on the end of school. Let's give them a nice, easy lesson for a change rather than a big honking hard one.
Maybe they just did the trust test and they were like, oh, they're idiots. They don't know midpoint.
Well, no, it wasn't that. It was more of the.
How would you know? You weren't there when they made this book.
Well, yeah.